So dear students, you are welcome in this practical class. And today is 3rd September 2022. Time is evening time and we are having a practical, online practical on determination of available nitrogen in soil. In the last practical, you got this all kind of clarifications regarding different forms of nitrogen in soil. We also discussed available nitrogen in soil. What does it mean? Now the turn is to estimate the available nitrogen in soil. Available nitrogen in soil, we discussed, it is mineral nitrogen plus potentially available nitrogen or potentially oxidizable nitrogen. Nitrogen that can be mineralized during the season will also be part of available nitrogen. Learning objectives are to know the chemical method for estimation of available nitrogen in soil. The concept of available nitrogen in soil, I will repeat again some important points. So available nitrogen in soil is estimated by alkaline permanganate method given by Subaiya and Asija 1956. So you can think, you can consider that Indian scientists have contributed handsomely in the development of different soil testing methods. Number of soil testing methods by Indian authors or Indian scientists are available, and they have been used by world over. So it is matter of pride for all of us. And principle of alkaline permanganate method is alkaline potassium permanganate liberates the ammonical nitrogen and hydrolyzes readily oxidizable nitrogen from organic compounds present in soil. The liberated ammonia is absorbed in boric acid containing mixed indicator. Distillation and titration is exactly same what we did for total nitrogen in soil or total nitrogen of the plant. Distillation and titration is exactly the same what we studied in the last practical. Only thing is extraction. Extraction of available nitrogen is different here. In total nitrogen analysis, we digested the same sample. Here, there is no need for digestion. Here, there is no need to decompose the organic matter. Here the alkaline permanganate will be able to extract the readily mineralizable nitrogen from the organic matter. And it will also extract the ammonical nitrogen. But it will not extract the nitrate nitrogen. That is the limitation with this method. It will estimate only mineralizable nitrogen or readily oxidizable nitrogen plus ammonical nitrogen. It will not analyze the nitrate nitrogen, this method. I read it again for you. Alkaline potassium permanganate liberates the ammonical nitrogen and hydrolyzes readily oxidizable nitrogen. Hydrolyzes readily oxidizable nitrogen from organic compounds present in soils. So that means it will do two jobs. One is it will complex the ammonical nitrogen. It will extract the ammonical nitrogen as well as organic nitrogen, part of the readily mineralizable organic nitrogen. Then same way you will take it to the distillation, where you will add 40% sodium hydroxide. The liberated ammonia is absorbed in boric acid containing mixed indicator. The amount of ammonia is calculated by titrating the distillate against standard acid. You can take HCl or H2SO4 like in the case of total nitrogen analysis. Here reagents are potassium permanganate solution 0.32%. This is in percent. Dissolved 3.2 gram KMnO4. The nature of KMnO4 is alkaline. Therefore, some people call it alkaline permanganate method. Dissolve 3.2 gram KMnO4 in 250 to 300 ml distilled water and make up to 1 liter. So that will be your 0.32% solution of KMnO4, potassium permanganate. Some of you might have seen it. In olden days in India, we used to have open wells for drinking water, and to kill the germs, people used to put certain amount of potassium permanganate in the water, and it used to kill the germs in the water, and then people used to drink that water. in the open wells. Now, next is your sodium hydroxide solution. Here it is 2.5%. I correct myself. It is not 40% here. It is NaOH solution is 2.5% here. Dissolve 25 gram NaOH flakes in 250 to 300 ml distilled water. Mix well and make up the volume to 1 liter. So here it is 2.5% because here the quantity of nitrogen is much less. Because in one example, you have seen if your total nitrogen was 2000 kg per hectare, then the available nitrogen was 140 kg per hectare. Therefore, you can take 2.5% sodium hydroxide because quantity of ammonia to be liberated is less. Liquid paraffin is required extra pure and you need 0.02 normal H2SO4. So in the last case, you got 0.1 normal H2SO4. Here you can take 0.02 normal H2SO4, diluted one, again because of lower levels of ammonia or nitrogen in the soil. Now boric acid mixed indicator solution, dissolve 20 gram of boric acid in about 700 ml. Room se le aao mere. 20 gram of boric acid in about 700 ml hot water. Transfer the cooled solution to 1 liter volumetric flask containing 200 ml of ethanol and 20 ml of mixed indicator. Mix the contents of the flask and add a little 0.02 normal NaOH solution until the color is pink. Make up the volume and mix the content of the volumetric flask. So this is how, this is simple procedure to make the boric acid indicator solution here. Mixed indicator, you can dissolve 0.07 gram of methyl red and 0.1 gram of bromocresol green in 100 ml of 95% ethanol. So this is how you can prepare mixed indicator solution. And then the procedure, just a minute. Now, procedure is transfer 20 gram soil. Here, in case of available nitrogen, it is 20 gram. In the total nitrogen, we have taken 5 gram. Soil in 500 ml Geldal flask. Add 20 ml of distilled water and swirl the Geldal flask gently. Now add 1 ml of liquid paraffin and a few glass beads, and finally add 100 ml of each of KMnO4 and NaOH solution. Reagent number 1 and 2. We prepared last time 1 and 2. These 1 and 2, KMnO4 and NaOH. Now, immediately after addition of NaOH and KMnO4, distill the content in Geldal assembly and collect the liberated ammonia in 250 ml Erlenmeyer flask. This is conical flask. Simple conical flask is also called as Erlenmeyer flask, containing 20 ml of boric acid. So here also you take 20 ml of boric acid, mixed indicator solution, reagent number 5. So in this ammonia will be collected. Nearly 100 ml of distillate is to be collected. In last case, it was 150 ml distillate. Here it is 100 ml distillate is to be collected in about 30 ml. Means when you have taken 20 ml boric acid, when it becomes 100 ml about 100 ml, then you can stop the distillation process. Otherwise, you can use the same red filter if no color change. That means the ammonia is already liberated. The color of the distillate is bluish green now, and titrate the distillate with 0.02 normal NH2PO4, NH2SO4, normal sulfuric acid, 0.02 normal sulfuric acid up to end point. The color change will be same as in total nitrogen. Same kind of calculations here. Available nitrogen kg per hectare, ml H2SO4 in sample. And here also you need to run a blank sample without soil. And then 0.02 is the normality of the sulfuric acid here. We have taken 0.02 normal. Yes, we can multiply by 0.02. And up to here, you will get milliequivalents, then equivalent weight of nitrogen 14. and then gram. You will get in gram, and then for 1 hectare soil, and initial sample was 20 gram, 20 gram soil sample. So you can get the factor also. This factor was calculated by Dr. Rajendra Prasad sir, who simply made it 31.36, and you can get two readings, ml H2SO4 in sample and minus H2SO4 plane. So 31.36, you get the available nitrogen is in soil. But this 31.36 will work only when you have these specified values, like 0.02 is the normality of sulfuric acid. Yeah, 0.02 is the normality, and 2.24 into 10 to the power 6 is the weight of 1 hectare soil. So any problem in procedure, principle, or calculations? No problem. So whenever you can come to IRA, you can have a try on these methods. Those who want to learn can come to the lab. This lab is open for you. You can come anytime and do this total N analysis and available nitrogen in the PG lab. Now, I just want to show you some reactions, how it is happening. What is the role of potassium permanganate? So how it is oxidizing the organic matter, how it is liberating the nitrogen. So you can see this KMNO4. KMNO4 plus H2O, water is there in the sample, and this permanganate ion is released on the reaction, permanganate KMNO4 plus 2 KOH. And interesting thing is the 3O is released. 3O is highly oxidizing agent. This is called as nascent oxygen. It is produced in alkaline medium provided by NaOH. I'm sorry, this alkaline medium is provided by NaOH to potassium permanganate. To potassium permanganate. MnO4 is permanganate ion. Now this nascent oxygen, this is useful in oxidizing the organic matter. Organic nitrogen is there in the organic matter. This is a general formula for organic matter nitrogen. You can say this is for amino acid, amines, whatever it is. So nitrogen is there in the organic form. And this nascent oxygen produced by this KMNO4 and water is will be oxidizing this. Sorry, this is amino acid or amines oxidized by nascent oxygen, and this ammonical form of nitrogen is received here or produced here. This ammonium can be dissociated to ammonia gas plus hydrogen ion in the alkaline medium provided by NaOH. Because NaOH and KMNO4 you are adding at the same time. So then this ammonia will be released by this NaOH. Now ammonia, when it is liberated and condensation happens in the tube during distillation, and then this is converted into ammonium hydroxide. You have seen distillation last time also. And this ammonium hydroxide, when it reaches boric acid, it is converted to ammonium borate or ammonium tetraborate. And then the color is bluish green. And then titration, the same kind of titration is there. Pink color comes here. So this is how some of the students would like to remember these reactions. The role of nascent oxygen in these reactions is very, very important, and which mineralizes. You can say this nascent oxygen actually mineralizes organic nitrogen. This is the main statement here. Now, limitations of alkaline permanganate method. The only limitation is that it will not estimate the nitrate and nitrite nitrogen. Available nitrogen, however, is mineral nitrogen, ammonical nitrite nitrate, plus readily oxidizable nitrogen after oxidation converted to ammonium. This method estimates available nitrogen including only ammonium nitrogen and ammonical nitrogen and readily oxidizable or mineralizable form from the organic matter. But this method does not include nitrates or nitrites. But it can be included if you are interested to get estimation of nitrite and nitrate also, then you need to add Devadas alloy. So first you use potassium permanganate and sodium hydroxide to liberate the ammonia. Once the ammonia is released completely from the distillation flask, then after a few minutes, you add Devada alloy into the same Geldal flask and start heating it again. And then whatever nitrates are there in the digest or extract, then they will be converted into ammonia if you add Devada alloy, and then that ammonia will be added into the beaker where you have boric acid mixed indicator. Already you have collected some ammonia from ammonical form and organic form, and then the same nitrogen will be accumulated there in the form of ammonia. So you can make two steps here by adding Devada's alloy. If you want to consider nitrate and nitrate nitrogen also. Two more slides are left only. Now, what happened then? Sehrawat and Burford, 1982. These two people developed a method, modification of alkaline permanganate method for determination of available nitrogen in soil. So, usual distillation of solution with alkaline KMNO4 using Subaiya and Asija method. First, you complete this method. After completion of this method, addition of Devada alloy 1.5 gram per sample have good recoveries of available nitrogen, including ammonia, nitrate and nitrite. So now Devada alloys, you should know a little more about Devada's alloy. It is composed of three metals: aluminium just metal in metal form. 44 to 46% is aluminium, 49 to 51% is copper, and 4 to 6% is zinc. So sometimes one quiz question can come to you. What are the composing or what is composition of Devada alloy? At least you can remember three elements or three metals: aluminium, copper, and zinc. Aluminium, copper, and zinc, they make up Devada alloy in different proportions. It acts as a reducing agent and helps reducing the nitrate and nitrite to ammonia, and which can be accumulated in the boric acid mixed indicator solution. So this is about Devada alloy, little more about Devada alloy. When a solution of nitrate ions is mixed with aqueous sodium hydroxide, adding Devada's alloy and heating the mixture gently, it liberates ammonia gas. After distillation of ammonia, the available nitrogen is determined by titration method. Now you can see the formula, the reaction, how Devada alloy work. Three nitrate is there, aluminum is there in the Devada alloy, and then hydroxyl ions are also there. You know, NaOH was added, and water is also there. So this reduces the nitrate. This aluminum reduces the nitrate, and then this ammonia is liberated, and aluminum hydroxide is formed. So this is how this complete estimation of available nitrogen in soil. So you can remember that this Subaiya and Asija method 1956 does not estimate nitrate and nitrite nitrogen. If you want to estimate it, use Sehrawat and Burford's modified method. So thank you very much. If you have any questions, your questions are welcome. I will be happy to answer any question on total nitrogen and available nitrogen. But so far, this decomposition of organic matter, I will very soon, I will take one lecture in detail because these are, you can say, artificial or decomposition of organic matter in lab by wet ashing or by dry ashing is also done in the laboratory. But in nature, it is decomposed by microbes. So any question related to this method? Anything you want now? I'm going to end this lecture or this practical here. So if you have anything in your mind, you can ask. Anything more? So dear students, we meet tomorrow morning, and tomorrow morning at 11. So it is just we are compulsory. You see, on Saturday you got some, on last Wednesday you got some midterm exam. So this class was shifted to Saturday, and one class I was taking every Saturday, that is shifted for tomorrow. So I can request you to attend the tomorrow's class from 11 to 1:15 or 1:30. So we meet tomorrow at 11. I am sending you the link. Thank you very much.
Thank you, sir.